Hello everyone, welcome to another stream. How are we doing? God bless you all. So last stream we basically just got this lovely voxel map rendering and sorting out a bunch of bugs basically, and the debug visualizations, making sure they're accessible via a settings thing. So I can just press F1, find the setting, toggle it on, and we can see some debug views and stuff like that. So that was super cool. So this voxel map is is this yeah, we basically had a voxel model system beforehand, and then I wanted to make a voxel map data structure basically that was using a 4x4x4 node tree that goes all the way down until you get to the leaf nodes, which represent the voxels themselves. So you can do this sort of you can only allocate what you need, right? Because some of the map might be empty space. So you can avoid allocating voxels for the empty space. And also so you can skip through when you ray trace through it. So you can skip a lot of empty space. So that was great that we did that. So the voxel models before, they were simply just a volume where it was just a grid, a 3D grid of voxels. So what we want to be working on today is taking this voxel map structure that we've made and turn it into the new voxel model structure. And I've already kind of done quite a lot of it off stream. It is a bit of a big task. I've already spent like 2 hours on it basically. But I'm most of the way there in the CPU side code, and then we'll be going to the yeah, on the non-renderer code, I'm most of the way there. And then we can go to the render side code and get that all changed over as well. So the voxel map is now just going to be a voxel model. And the reason why we didn't do this in the first place is because I thought the voxel map was going to be a completely different data structure. And it was going to be initially, but then I found out that it wasn't going to yield it wasn't going to yield that much savings in RAM, and it still would have meant that the full voxel map would not fit in memory. So yeah, so I decided to make the voxel map simpler, and then it basically was compatible with like a voxel model format. So I decided to. So now we're moving towards a sort of voxel model 2.0. We're just improving off the one we've already got currently in there basically now. That's cool. But yeah, any questions, feel free to ask away. There's a Discord channel. We're going to come and chat off stream about things. And there is a YouTube channel where you can find the streams get uploaded there. And also there is a way to support the studio and towards the project that we're currently going towards. So if you go on YouTube, there's a video which describes the game that we're working on basically. We're just doing the graphics side of things so we can get some prototype graphics and get going basically. So yeah. Right, let's do a prayer, then we shall move. We can talk about the code and get started. Father in heaven, we thank you, Lord, for this day. We bless your holy name. We thank you, Lord, for providing us everything we have. We thank you, Lord, for your divine protection over our lives. Thank you for keeping us alive and keeping the enemy away from us. All the things that you've done behind the scenes that we don't know about. Thank you, Lord God. Yeah, we just pray, Lord, that you help us today, do your will. Help us hear your spirit, listen to your spirit, and be in your presence always. Help us not, help us deny the enemy whenever he shows his face in our lives, and lead us into paths of righteousness for your name's sake. And Lord, prepare that table before us in the presence of our enemies, and anoint our heads with oil, and let our cups overflow to the people around us. We thank you, Lord. We bless your holy name. In Jesus' name we pray. Amen. Cool. Want me a Coke? yeah, so I guess I can leave this sort of just floating around, maybe as just an example of what we've been working on. Just leave it up there. Oh. Now, so essentially we've got this, I'll talk about the file structure at the moment. So we've got a modules folder where it's basically like a library, but it's not really a library, right? Because that would be, they do get compiled as individual compilation units, basically, each of these for the most part. So we've got, I had a problem where the voxel, I wanted to share the voxel data structures between the graphics layer and the game, which is in another place. It's out here basically in games and game, right? So I wanted to share that module that code between two places. So I made a new module for it. And turns out it's been quite a good idea because soon when we make a new this new voxel model format that we're working towards, we can use that module for the voxel builder, which takes the Magica voxel files and turns them into this our internal engine format for voxels, right? This 4x4x4 tree node thingy. So that's super great. So what we're editing at the moment is that sort of voxel module side of things, where it just basically stores all of the voxel data. So we've got a public API. So I've changed it now. Rather than being voxel map, it's now called voxel model, and it's most of the way there. And effectively, you have frames of animation, and I used to call them like a frame called like a model slice, but it just makes nice. It's like a 3D slice of a 4D thing, but so I just called it a keyframe because that's what people know it as, and it's, you won't be questioning what a slice is and what a slice isn't. So yeah, you can initialize and you can mark it for deallocation, and then it gets deallocated about 7 frames later. Just in case we do some sort of networking and do some rollback, we've got a system in there already mostly done. So the whole point of this API is you can actually make a new model and you can edit it, right? So the map is going to use this, and so is the voxel builder. And maybe if we want to do some procedural models, we can do it this way as well, which is great. And internally, it still does things the same sorts of way, or the same way. It has this sort of like pool, so it's called a voxel map node pool, but now I've changed it to a voxel model pool. So it allocates nodes, which are these 4x4x4 nodes, which just hold more children until you get down to the leaf nodes, which are the voxels. And then it holds, there's a separate one, which is like the voxel material indices. So these are what material to use for the voxels when you allocate the voxels, and the keyframes for the models, and also the models themselves. This is what the pool is good at doing, basically, is allocating those 4 different things and also breaking them into pages as well. So basically, when you change when you change a model, when you change a node, when you change any of these things, we have a page bit set where we mark which pages have been changed, and then those will be asynchronously uploaded to the GPU. And this is another great thing about using turning the voxel map into this new voxel model system and getting rid of the old one, is because the voxel map supported async upload. Like, we basically wrote that because we needed it. And so now the voxel models are just going to get that by putting it all into the same system, which is pretty cool. So I think that pretty much describes everything. So there's just one global pool basically of memory. And so that means when you boot up the game, you can just say to the Voxel cache system, right, I want this many models at most. I want this many keyframes at most to be allocated, this many nodes, and so on. And then it can do, and then we, yeah. And then we've sort of fixed allocated everything, which is super great. Cool. So let's carry on through here. So I changed the voxel set function. So this used to be called voxel map voxel set, but now it's voxel model keyframe voxel set. Bit wordy, but it's what it does. So basically, I've made it return an error now. So it can have no error, which is what you want. You can have an out of bounds error, so you've just literally tried to write out of bounds and it's done nothing. Or you can have an out of memory error, right? So hopefully you can handle it, or I guess you just assert if you can't handle it. Well, I was trying to avoid crashing. But yeah, hopefully you can handle it. That's the idea. Pass the responsibility out. So this one here now returns a kind of states on how it went. So at the end here, we are just going to return a success message, the fact that the error is none. Now, how do you get out of memory? Right, that is a very good point. So this sort of find leaf nodes for write. This is, so essentially you start the root node, wherever that is. Oh yeah, so you go into here. So it basically starts at the root node and just traverses down the tree. These 4x4x4 things, right? And essentially we, how's that showing up? Yeah, I think it's all right. Okay, so it just keeps traversing down the tree, basically, the layers, and allocating nodes if it needs to. So you could bump into a case when there is a failure because it was out of memory, right? So yeah, so essentially these alloc functions, and maybe a realloc as well. But we should ideally make all these alloc functions handle out of memory. I think we do. Yeah, that of memory is just 0, 0. Okay, so if the end is equal to 0, then it's a out of memory. So if by range.end equals 0, then return core range u3200, yeah? And we just want to plaster that in all the places, in all these alloc functions. So for the keyframes, for the nodes, for the well, yeah. Yeah. So it's U32 max for that one, but so it's a bit inconsistent, but I think it'd be fine. So let's chase this one around for a minute. So this is the voxel model. So if when you make a voxel model, if that is equal to 0, then we can return a null ID. Okay. And then, right, it's the one place it does. Now, allocate nodes. So this is, it does it in a few places, which is kind of annoying, but it's the way it is. So if new start, can't do that. Yeah, you know, I would wish that it would be great if it actually returned U32 max. Well, no, return U64 max. Right, okay, so these ones should just return. And that way they'll be consistent inside this module at least. Cool. Anywho. Right, so if you're trying to make a new root node, if that start index is equal to U32 max, then we can simply yeah, I wonder, we never really need, we always just do a dot start on it, don't we? Right, let's change the API then. It already knows. So we can just make that a bit easier. Okay. Right, so this find leaf node for right. So again, starts at the root node, traverses all the way down. So if the root node is invalid or has nothing there, well, that's interesting. So when we instantiate the model, we need to go over and poke all of the keyframes. So I'll be in 0 keyframes count, pull keyframes, and there's a keyframe start index. Well, we could just do this, right? Yeah, so range start, range end, index. Right, so we said it's some kind of invalid value, the root node index. So when it tries to write to the tree, it can spot that and do nothing. So we try and read and it's not been allocated yet as well. That is interesting. Yeah, that's going to be a problem there. So if this root node right, so we've handled that issue. So for the right, which is the voxel set, which is the one we're looking at, we want to say, right, if the root node failed to be allocated. So this code is basically saying, right, if it's not been allocated yet, or it needs to be allocated because we're trying to change it this frame and it hasn't been changed yet. So it's like a copy on write thing, basically. So we can have the data mirrored from the CPU to the GPU, and it's still, way of saying it, the future frames can just point to the different data, basically. And then the ones which happened a few frames ago can just retire after so many frames, and that way we can support like basically rolling stuff back and replaying it and that sort of thing. But yeah, it might be a still require a bit of work, but at least we've thought about it ahead of time a bit. Yeah, you might have to, if we were to do a rollback, we'll have to somehow clean up the state which got generated since then, but it's, yeah, this stuff we can do. And new root. Yes, this failed to allocate, so just returns to let it know it failed to allocate, right? So mark for deallocation. Now, we want to find where it's doing more allocations. So does it need allocation? Yes. Now, this is this sort of reallocate children function. This one, yeah, it's just a convenience function, basically, just to, as it says, right, reallocate the children nodes. So if it's able to reallocate, then shuffle. You copy old to new. Yeah, and then mark the old one for deallocation. Perfect. So this. So removing a child requires memory as well. Bum bum bum. Yeah, so it's kind of an issue if sometimes if you could run out of memory. Just been trying to delete stuff basically, which would kind of suck. So the delete happens when, so that's when the resize happens, right? Yeah, so a resize could get out of memory. And then if that's true, do you like, because it would suck to end it halfway basically. You know, you could leave it in a sort of a not very optimized state by having some nodes which are sort of dangling. But yeah, for now, I think I'll just put an assert in there because we're not really going to use this code too much. But when we do need to use it in a particular way, we can. There's the realloc children, wasn't it? Here, so we do a core assert. This is not equal to E32 max. And we'll say to do handle out of memory. So this one is inside that find leaf node for write. So when you try and set a voxel, basically uses this to traverse down the tree and keeps allocating new nodes if it needs them, or just finding its way down to the leaf node. So if this is equal to E32 max, then we have a problemo because it's failed. And thankfully we should just be able to return here. There's not anything that's sort of left half done. Then, yep. So is there any more allocations that go on? Let's have a look. Right, so this would have reallocated the children. And then, so it would have copied them and everything. Then now it's trying to sort of shift and put them into place, I think it's something like that. So if the child is missing, yeah, shift right, 0 the new element for me, then mark that this node hasn't been mutated this frame, basically, to the new child node. Then allocate its children, basically. So if you fail to allocate the children of this new node that you've made, I wonder if you can set it to be something else. And then, like, so if you can set it to be a different value, you can say, like, it's not allocated yet or something. And then later on, when you're going down, if it's not allocated yet, allocated then, but then you got the same problem where the node is not allocated yet. But it could be a state we can handle in the renderer. Yeah, that's possible. So I think if you set the whole thing to be U32 max, you can say it's not allocated yet. So you can 1 the element, right? 1 it. If you 1 it instead of 0ing, then you can so if any of these fail to allocate, then we can return. But we can't do that here because it's going to leave it in sort of a half set state when you next come around. So what you want to do is like, right, as you're traversing down this tree, where's the cold? So you get the cold for the node. What do you do with the cold? I think what you want to do is say, right, if cold auxiliary, not auxiliary, if cold whatever the whole thing is, if that is equal to E32 max, then I'd like to allocate all of these guys. So now, if you get this is no longer a child because it's the node itself. Is this a leaf? That's a good question. So you need to say, if you don't know if it is a leaf now because the leaf comes from the cold bit field, it's the first bit or whatever it is, or the last bit. So that would be, because with 1 bit it's messed up now, but oh, how you know if it's a leaf is if the node depth is equal to node. So bool is leaf is node depth equal max node depth. Amazing. Allocate nodes. If not, allocate the voxel material words. If any of those fail, return, and that means when you next come down here, it can handle that. Sorry, when you next come down here, it's going to actually allocate it properly again when it or try to at least. Cool, that's really good. So we can then set cold as leaf to whatever is leaf is, and then we can set the start index to the right value. Amazing. Cool, I'm happy with that. Do we want to say that it's been changed at this point? mark it's been updated. So it would have come through here. Yeah, we want to kind of mark like this child for being updated, but I guess you can get its you need to get it's the first sibling node basically. So you could just store that as like, hey, give me the previous. Will kind of suck, but it's a way of solving it. So it's the first sibling index, and the count is it's not the best though, and that means every single time you access. Nah, it does work. Or just previous node index. So with that, you could basically get the auxiliary. So you can call it like sibling. Sibling, and then like siblings count. So that would be auxiliary of your parent. There's the address of node cold. Yep. And then you also want to get the, it's another one. There's the hots, I think. And you want to count the number of children, so it's it's this one here. Cool. So we mark all of the sibling nodes as saying, hey, these have changed. So it'll find the page that they exist in and mark the bit in the bit cell, which represents that page. And a page is like 4,000 elements, right? It's kind of like an operating system virtual memory page, but it's its own thing, right? And we will then asynchronously copy all of that stuff up, which has changed. So this is a great change. So yeah, we're just going through and just making sure that we can return that we've failed to allocate. So operations can fail, and we can at least handle that somehow. Outside. So as we keep going. So alloc. I don't think that's going to change anything else then. Right, that's good. So this now, we've got this lovely change to this find leaf node for right. So if this now returns E32 max, we can now return from this that we've actually ran out of memory and we couldn't allocate any new nodes or anything like that. And any nodes or voxel material indices. And so literally stuff has to be deleted for that to yeah, stuff has to be deleted. I wonder if you can get into a bit of a pickle where you've absolutely max allocated everything, and to free something, you always have to reallocate something else. Sometimes. Yeah, in ways you could get in a bit of a pickle. So the idea is hopefully you just allocate enough memory and never run into the problem. But yeah, hopefully you can gracefully handle all of it. But at least it's just a step in the right direction, hopefully. Okay, so I'm glad we've got this in there now. So what else is there that's left to do in the Voxel module? I think we're most of the way there. Let's just... Right, apparently there's no compile errors. So we've got the ability to make a model, deallocate or mark if deallocation. Set the dimensions of a keyframe. So this one could fail. I don't know. Like this one. Oh, that's a very valid point. Right. Remove leaf node. Hey, why doesn't that... So that's in Voxel set, isn't it? Oh, keyframe. It's not very nice. Anywho. Yeah, so this one could also mean it's out of memory. So what you'll come across is an air voxel, right? And yeah, you would literally come across an air voxel. Would you? No, at this point you failed to remove the leaf node. Yeah, remove child is where the problem can happen. Because it's got to allocate something new. But it is making it less. Yeah, so if it is just making it less... Yeah, this is how we can do it. So if you're removing a child and you go like, okay, we can actually shrink this volume now to something smaller. What's the way of saying it? We have all the children sitting next to each other in memory. So there's like the hot nodes, which basically just hold the bit set. So it's a 64-bit int basically, and the cold, which is basically just an index to, well, there's 1 bit to represent if it's a leaf, and another 31 bits which holds an index of where the children of that node live. So all of the sibling nodes sit together next to each other in memory, okay? So yeah. So when you allocate the children, we don't allocate 64 nodes and just call it a day. We actually allocate as many as fit into a 64 byte cache line, and we basically smartly pack them in based on which children exist and which ones don't. So that's all worked out based on so you can take a child index and you can work out, like, based on, by counting the bits, you can work out which index you actually are at. Yeah, by masking out some bits and counting the ones which remain, you can work out which packed offset index you're at. So this allows us to reserve and save memory because we don't have to, for some of these which don't have nodes, what's the way of saying it? Yeah, for places which don't have many nodes allocated, they can use less memory, right? The downside is you have to reallocate when it becomes appropriate. So we're removing a child from a node, so now all of its children could be reallocated if it's gone past the boundary. But this is only, this is interesting, because it's shrinking, it doesn't actually do anything other than we're just wasting more memory now, right? So that's kind of cool. I just wonder though, does this code doesn't handle the fact if you remove them all, does it? Yeah, so this one handles here if they all don't exist, then delete it. So maybe you just do that as part of this, but then hang on, that's the same sort of code there, isn't it? Yeah, this is saying if it's empty or if the node is out of bounds, then delete it. It's a bit different. Yeah, but if the child is out of bounds, it would have removed the child, and therefore, if the whole node is out of bounds, all the children would have been removed by the time you get here, right? So that means then all of this could actually just go inside the removed child, just right at the end. So what you say is, if from this node, when you remove the child, if there's nothing in there anymore, then you get the old children count and just mark it for deletion, and that's gonna obviously not cause any allocation issues. Right, that's really great. But yeah, this is saying, so this is not a leaf, so it's not got voxels there, it's just got more nodes. And your new count is gonna be 0. Then Yeah, what's the point of doing the mem move? Just, it's silly. So if it's greater than 1, yeah? Then do that. Hey there, Alex. Yo, does C have a keyword in place of and? Oh, you mean just to make it like, so you can say and instead? It doesn't, but you can make your own. Like that. Yeah, you can just do your own with define. So you can end up just doing if. Yeah. So you can actually, you can do these, right? But you're better off just doing capitals, I guess. Maybe, or maybe not. I don't know. You can probably do not as well. If you wanted to. Make it read like English. But the not has to come first. So if not test. Are those C++ keywords? But yeah, if you use defines, it gets around the fact that they're keywords as well, because the define will redefine it before. C++ and or keywords. See what the AI is going to give me an essay on. But it's better than using Google search, let's be honest. Oh, they have them. When do they come in? C98. Oh, I didn't realize that. Wow. I've never seen these. Like, you know, there's a famous thing. Was it Carmack said it? Maybe, maybe not. Where he said, if you use C++, basically every feature in C++ will get used inside the code base one day. That sort of comment. And I've not seen those yet. Interesting. Yeah, I can imagine it is. You would expect, though, to have come in because, honestly, the amount of people you get programming in C++ who prefer high-level languages, you would expect to see it more. Right. Interesting. Interesting. Oh, you stream as well, Alex? You stream on your project? Ah, fair enough. What are you working on at the moment or these days? Right, so if we get out of memory, then that just means, so we can just say like here. So we can say got out of memory. Oh, come on. Oh yeah, cool. So we can say got out of memory, but it doesn't matter. Wait, there's a shift left. Yeah, that's fine. The only issue is the bit set is going to report that like the children count is different from what is actually allocated. Right, this is an issue. So when it next comes around to try and clean it up again, it's going to pass in a smaller amount. And that will eventually leak memory, basically, because the allocator will be fed the wrong sizes. So we'll miss out a cache line, basically, here and there. Ooh. Hey, Buzztronic, I've seen people use that on those, there's those like crazy C libraries that use the C preprocessor to like completely change it into like a really different language. And they do a lot of like heap allocations and stuff. But yeah, I've seen those use it. But I'm not sure any serious code base, but maybe. Do you have a like game getting close to 2,000 lines of C++? Sorry, 200,000. Wow. Yeah, I'm not sure what I got right now. I haven't got clock on this machine. I did it on Linux. Maybe I can install it one day. So that's 200,000 lines of your own code. Is that right? Because you can easily get that with third-party libraries, right? Oh, the white space programming language. I think I've seen that. Wow. Amazing. It's a lot of code. Hopefully you can manage it. That's the only issue with long code. Yeah, I remember you saying last stream you had like, you got more gameplay code than you have rendering code. Oh, full time as well. Yeah, interesting. Oh, damn it, we can't. There's something we could do is mark it just to be like, hey, do this later when there becomes memory to do it. Realloc just seems really dumb. Because why didn't you just shrink it? Yeah, so what we should be doing instead is actually just saying no, deallocate. Yeah, I think it should work. So yeah, we shouldn't do this reallocate children thing. Instead, we should do a different thing where we just say no, deallocate a range. Do 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 do. Yes, we can't make it possible to get out of memory. Okay, this is great. So you'll look at this in a sec. Yeah, so unsets whether it's been mutated or not this frame. And we want so we've shifted everything to the left that could go left. And we want to take the final page. So I guess what you could do is just say, right, the new or old children count, and then whatever the children's start index, and then minus to be end index minus a voxel model is it like a cache line? Nodes per cache line? Yeah. Do we mark that as being freed? It's going to check for an allocation. Allocs. Yeah, so this might trigger, but we'll handle that in a bit. So we would partially deallocating we're partially deallocating, not full deallocating. That's okay. We haven't done it yet. No. We need to like an int round up to multiple, I think. Yeah, maybe. That'll perfectly fit into a cache line, which will make it a power of 2. Yeah. Cool. Yeah, you don't have to worry about setting that then, that's good. They'll never be allocated again. This frame? Okay. Nice. Amazing. That's great you have it on Steam. Yeah, I wonder if I want to go to Steam right away, you know, because I might just put it elsewhere first and then do more of a sort of full release on Steam, but I don't know. But Steam is where the audience is, isn't it, basically, usually? So yeah, stuff to think about as we get closer. Yeah, so now that's there's no longer a way to get out of memory when doing a remove anymore, right? Because we just shrink rather than we just deallocate rather than reallocate. Right, much better. Cool. So there's this code now. So this was the one where it was like, hey, remove the leaf node. So this happens when you're basically setting the voxels and in the 4x4 you realize, hang on a minute, it's all empty space. So you're basically saying, right, remove that leaf node from existence, and it could actually end up trickling up the whole tree and removing more things. So yeah, we traverse the way down again basically and get a stack of parents because we don't have parent links in the tree. So that's fine, right? Then we go down the tree in reverse order. Sorry, so go from the bottom of the trees back up. And we basically deallocate. So this was removing. Well, what is this doing? So remove child. Hmm. But this is removing the child. Yeah, what is this removing? So the node, and then getting the child, then getting the child node, and deleting its children. So really what you want to do is that leaf. Where's the break? So yes, the current node index, and there's a bit of shadowing going on here. But yes, that last node index, that is the one where you actually want to delete it like this. So maybe we can call that deallocate node and make that a function. Yeah, hopefully the compiler's inlines all of this and, you know, optimizes some of this stuff, but hey ho. Not the end of the world if it doesn't. Maybe we could make into macros later if it's really a big deal. But there we go. So cool. Right, so got this lovely little function now. So like this whole remove leaf, you know, find the leaf, right? Now remove the leaf. Now traverse up the tree to see if there's any so we can get this rid of this now. Traverse up the tree. Traverse up the tree to see if you can get rid of any sorry, remove the child and see if that node can also be removed as well. Okay, so Where was this one used again? So yeah, remove if outside. So keep traversing down the tree. And yeah, I wonder if we need that as a separate dialog thing, to be honest. Like, you might not need it as a separate dialog because it's just the way I've done the loop. So where is it? So after you go around here, right? That's great and everything, but no, it's about removing a child. Yeah, but the leaf node is just going to have... Right, this is fine. Right, so we'll go into here and we could say... Yeah, the marking... Marker 0, unset, empty, then deallocate. Yes, I guess what we could do is we could... this is just more optimized. This is better. Right, we'll keep it. Cool. Right, so I'm glad we sorted that out now. I think that's all the main issues with this sort of voxel module. Just complicated tree stuff, but it's basically there now. So what is next to do? Well, so now we've got this new sort of voxel model thing. We can make voxel models and they can have a certain number of keyframes, and the keyframes can be, you know, they can be set and get basically. Now the next thing we want to do is change the upload code so it gets uploaded to the GPU again. So what we can do, so let's go to the GPU internal. Is there a voxel model in voxel, what do we call it? Voxel what? Map. Anything like that, like a map. Right, so this will like generate material. Yeah, all this stuff can just go. It was not really a good idea. And the ref as well from the payload. So yeah, I think a lot of this stuff is just going to ultimately go. The voxel model generate and all of this. We'll get rid of it in a bit. Let's just get rid of the map. But this one's different. This will be called a voxel model pool upload async job. This is going to be awesome. But from the game side, okay. Let's go into the graph. Let's go and just write the user code for it. This is our guy. Right. So it used to be called a map node pool. Now it's a model pool. Right, so we call this function called upload, and it gets all the upload data from all the internal state basically that we need to upload. And it just goes over all these pages and basically allocates, sorry, puts them into the upload buffer and off they go right now. And it does a bit of everything. It does a bit of nodes, it does a bit of voxel material indices. So I think we'll just add more things to this basically. So we're adding a few new things. We're adding the voxel models themselves because now we have multiple models, and that's what a map is now. It's just a voxel model. And we had a voxel model before, but the old one will go away, and this new one is going to replace it. That was interesting. That'll be good to sort that out. Right, so there's a bunch of stuff called map this, map that, right? So we can just get rid of all that, map this, map that, and voila. And all this other stuff will be changed as well. And so be map underscore, just get rid of that, map this, map that. All the map render, we'll sort that in a bit. I'll see what's going on. So voxel map. Right, there's a bunch of stuff that needs changing. These are the hard-coded GPU IDs for the buffers, basically. So they can just be fixed in shader code. Just hard-coded indices. Cool, let's sort it out. So let's do map underscore. It'd be like a cache. Not sure why that was not a cache. Oh, yeah. That'll be a thing at least. Maybe not. Cool. Alright, making our way there now. So where's that other code gone? It's the job, isn't it? The async job. Right, we're back here. So again, it's just going over one page at a time. It's kind of a bit dumb the way I'm doing it, but it might just be the way to... So atomically reading one bit at a time. Yeah, it's not really the best. Yeah, let's just keep it this way. I can't be bothered to make it better. Let's just think about it quick. So you can read a whole U64 anatomically, right? Then just do least significant bit and that sort of stuff. And then do least significant bit and then Yeah, maybe that's just the way to do it. So the pages end up being, yeah, how much they end up being, to be honest. It's just one page and upload, so there are 1,000 cache lines. Right, so 64K we upload. So yeah, I think we'll just do, we'll maybe do a word, page word, a page bit set word index, maybe. And that way, I'm probably just have one of them. So if you do your sort of like atomic node voxel material indices. These are your page bit sets, I guess. Or it's the word, isn't it? Yeah, it's just already preloaded, basically, bit set word. And the other one, there's two more, right? There's a, oh, okay. Let's get these changed over to just much better code, and then we'll add the models and the keyframes. So effectively, we're just saying, right, while there is stuff to upload, we probably don't need these anymore. Yes, we probably don't need these pages cap. That'll be quite nice. Get rid of those, basically. I wonder if you could do voxel internal pages cap. I wonder how much of that you can just get rid of, because it's less data in the structure. Cool. Seems to be able to get rid of those as well. It's very nice. Right, so back to here. So we basically just scan over all these words. So there's actually a bit set words capacity, something like that. Updated. Okay, they're a thing. And then what else we doing? This page index thing again. And update page bit sets words capacity. Perfect. So what we want to do is basically say, right, while this index, or while, like, yes, we just want to find when there's something new to upload for each of these things. We just do a page at a time. And I wonder if we want separate indices in places. Um, so maybe the code is something like, right, while the bit set, this bit set word is equal to 0, and this other one is also equal to 0, and then we try and load the next one into it. So I guess we can then say, right, bump the word index, and then, right, so we'll do that, I guess. And then we also bump the page index, and then we do your if statements and basically check if this is still true. Like, or if any of these are out of bounds, if both of them are out of bounds, then we can actually bail and be like, well, we failed to find anything. And then then we want to read the word in. So I guess you do your atomic load of this bit set. There's the address with the page word index thingy. And then you've also got another one, which is the voxel material indices. So you load those two guys in. Now you could have an out of bounds check here, right? Sorry, an out of bounds issue here. So I think you want to say yeah, so the issue I have with this though is you're gonna skip page 0 always. Yeah, I was thinking about setting this to like U32 max, but you know, then this won't even get past here. So it's a big old problem. You know, you could turn it into a signed integer and then use -1. And I think that might be fine. It'll be a bit weird. I never really used signed. But that'll do it. So now we're saying, gotta be careful how we're using it though, it should be fine. So that'll go from -1 to 0. Then if it's out of bounds, problem is it's signed now, isn't it? Unless you just do a thing where, you know, really what you want is a do while at this point, I think. Is there a continue? There's not. Okay, so you just put it at the bottom basically, then invert it. Okay, I think we're in a good place there. So that's just a while one. Or it could be do while, but I never managed to write successful do whiles. They always end up wrong. I always end up never needing a do while when I write one. So I just give up writing them these days. Right, so keep stepping. Sorry, U32 max. I get to do that, which is super cool. Rightio, so we have so it goes from U32 to 0. If they go out of bounds, then okay, break. These will not run, and then it will basically break out again at the end. But if not, grab the latest word, and then hopefully they have stuff in it, and then this will end. Okay, so now this is optimized to essentially get the least set bit, and then remove the least set bit, that sort of code. So what we just say is basically, right, if node bit set word, it has stuff in it, right, cool. Right, we want to, we're crying out loud, atomic exchange. So exchange to say now they're not used, right? Just a swap. And so now we no longer need to do an unset. That's proper cool. So we're basically trying to find, it's like, right, what is the page index? How do we work that out? How do we work it out? So it's page index equal page bit set word index times 64, I think. Right, 64 pages in a bit set. So then to work out this one, it is basically node page index equals, well, we can call it base page, plus bit least significant bit index of a U64 node bit set word index, right? Now we have to remember to call this sort of node. I've got a function called call bit remove least set bit. So this I think just does an and of itself take one. I think that's what you do. Yeah, memory. But yeah, I got it as a function so I don't forget it. And so it reads like English. So you want to put that down here basically. Now, the issue is with this code is the fact that actually we could fail to upload, and now these bits, like, yeah, so we want to store it back in the bit set basically, of all the ones which are remaining. So we'll remember to do that. So, right, so we get the async upload buffer. Yeah, we say we want to upload basically, and we write into the upload buffer. We do this sort of range. Now if we fail, we want to store back in the bit set. So it'll be an atomic OR. And the OR is going to be a you want to do this again. And you're ORing back in the node bit set word that you've extracted out, right? And that's great. Then you do your upload. And then again, it could also fail on the cold side. So you just do your upload again. Yeah, you just upload it again if you fail. So we mark it to say like, oh, these pages are still updated. And then if successful, we remove the least significant bit. Cool. So now this code can go here. And now we just got to adjust this one here. So the voxel material indices are more simple because they don't have like two arrays which are parallel. So it is very similar though. So I want to do this. And rather than node, it's voxel material indices. So we don't do the unset. And yeah, so we work out the page that we want to upload basically. And if we fail, we want to re-upload the whole word back into the bit set for a future frame when there's room to upload to the GPU. Right, I'm super happy with that. That's great. Super great. Now, oh, that was nearly a copy paste bug. Okay, we're good. Yeah. So the rest of the code doesn't really change. It's still the same sort of thing. But this is just the piece of code that basically lets the render thread like know that the whole thing has been uploaded from beginning to end and everything's been uploaded, which has been marked to being up which has been marked as changed, has been uploaded to the GPU now. So the next time we render, we've got a semaphore for a command buffer which we can wait on basically. So what we're going to do now is add support for uploading models and uploading keyframes. So these are the new things that we've got in today because the voxel map is now just a voxel model and this is voxel model 2.0. So where's our guy? Right, so we've got a voxel model here. I wonder if we can like pack this down because it's available on CPU and GPU as well, isn't it? Yeah, let's move this into yeah, it needs to be at least 8 bytes though, I think. All right, here we go. So we've got it in the encoder file now. So we should be able to bit pack to our heart's content. So I reckon, right, surely you don't want any more than 256 frames. So doing something like this is probably possible. So you're just limited to, what is that, 16 million frames. So that should be enough, right? Yeah, 16 million. That's all right. You could probably pack this down at some point, but there we go. That ought to be good enough. Now, the keyframe. You know, the frame indices probably don't need to go onto the GPU because it's all controlled via CPU side code. The animation, at least what keyframe the instance is pointing to, is all controlled by CPU code. But yeah, you know, the voxel dims. Right now that's 5 UNITs. Yeah, 5 U32s. We could probably pack it down even more. So the root node index, you probably need a whole up to 4 gigabytes, I reckon. You need pretty much all of it. The frame index, you could put that into a separate array and then only use it CPU side. Never upload it, that saves memory. And that's 4 UNITs. But the dims you see, yeah, I reckon what you can do is this. You can just do dim x 16. Oh, no, but the map is going to be like... Oh yeah, this supports up to 64K map size. It's quite big. Like if you're going to be doing like... Sorry, 64,000 in it, so it's... And then that's the power of 3. It's going to be like stupid. Oh, come on. I kind of just remember. Mm. Stupidly big number. So it's killer, mega, giga, teravoxels. Yeah, so that's a lot of voxels, right? You're probably not going to be doing that. The map that I want to do is like 16K by 16K. Obviously not all allocated, right? Because it's a whole tree, but you see the point, right? It's a big space. That's probably enough. So you probably pack that down like that. Then you got a final 16 bits that you could just pack this down into as well. And then it all fits down into, so that's 2 UNITs. And then that's the third UNIT. So you can do this thing where it's called accessor U32 times 3. And just say dims, I think. I think that's how you do it. Just double check. Yeah, that is. Cool. So I'll code generate all the things that we want and need. So that is super cool. And then if we don't need the frame index, we can always put something else there if need be. But it's there anyway, just in case. So yeah, now we've probably busted the Voxel code that we just completed. Voxel C code, but it's not too bad to change. Not sure why this is complaining. Right, you're supposed to... It's supposed to be building... Oh, okay, it's good. Built it now. It's code generated now, which is cool. So what's next? Wow, Row got some compile errors. Yeah, so we're supposed to have the shared, but it's right there. There it is. Lovely. We've got the accesses. So yeah, why are you complaining? Oh. Right, keyframe. Huh. There's the keyframe. Yeah, why are you complaining? Maybe there's half written code somewhere and it's just like an open bracket or something. Oh, what's this? Oh. I've code generated a new macro, which is actually the same as this function name. Of course it is. Crying out loud. Right, so we could just call it resize, and that'll probably be better. Cool. Right, so we're going to go ahead now and fix some of these errors. So this will just be a voxel model keyframe start index set. And there's a count set as well. Remember, we're going to deref these because it works on GPU as well. Nice. So this will just be voxel model keyframe dims, and we'll extract out the dimensions for us. Unpack them. Got a deref. There we go. So that's going to be the old dims. Oh, interesting. That's found a bug because we would have messed that right up, I think. It'd been real bad. We want to traverse down the old tree and delete the inactive nodes. Cool. Right, so get a keyframe from a model. So keyframe index. So you can do the keyframes counts. So voxel model keyframes. Keyframes count. Oh, wait. That's in the... Right, there we go. It's in the model. Noise. Similar sort of thing. Right, to get the dims. Right, getting there. Nearly done now, not too far, I don't think. Right, so I think that's all the errors sorted out in the module, in the voxel module that we just introduced. So now we can hop back into the graphics code and upload these to the GPU now, which is very cool. So we've got the new packed data structures, the voxel model and the voxel model keyframe. So we'll have to make sure that we make new buffers for those and stuff like that. But yeah. Right, be right back. I'm just gonna get a quick drink and then we'll get back to it. But yeah, any questions, feel free to ask away. Right, welcome back. Okay, we're getting quite far now. What's left is we have to finish this upload async function, just get it adapted to upload voxel models and voxel keyframes, then change the rendering code that the voxel map ray tracer that we wrote the past few streams. Just move that into the voxel model rendering code, the old one, and adapt it. It does occlusion, culling, and all of this. So they each had their own strengths, and now we're merging them together. The voxel map had async upload and 4x4x4 node tree traversal, but the voxel model didn't have that. But now we merge them together. They have the best of both worlds, which is super cool. So yeah, then after that we can like basically delete some old API, the old voxel models, and then change the game code, and then it should just work. But yeah, we're getting close. Lots of fun. Right, so we want to basically just keep track of the model's bit set and the keyframes. Now we, again, same sort of thing. Model, keyframes. This thing. Right. Model, keyframe. Okay. Yeah, these things are not really consistent with the plurals, but oh well. It shall do. Now, so that gets the next word. Now, the one we're best on copying is this one because it's just a single array. Bit lengthy though, but it's anyways. So we get this one. We voxel material. So that'd be model. So that underscore words buffer is not a thing. Models buffer. We've got to make one of those. I think we have an old one floating around, but yeah. Cool. So that's quite alright, although this is a bit weird. Indice. Huh? Oh, we don't even have the pointer to the data yet. Wow. Okay. I need that. Voxel model. Models. Keyframes. Yeah, we need those. Let's just fetch all that data. So it'd be out models equal pool, model pool, entries, out, keyframes equal pool, keyframes. It's just an array. Cool. Anywho's, back to here. Oh, what else is complaining? Nice, so now we just copy this one and do it again one more time. So rather than model, it's be keyframe. Oh. Oopsie. Right, I think we're in a good place. That's good. Right, so this should be the async upload code adjusted now to work with models and keyframes. Very nice. So now we've just got to go ahead and change the rest of the renderer. So great. So the next thing we need to do, so we could maybe change the outside in, kind of. Let's change the public API. So we've got this thing like a voxel model render index. You know what, let's leave it alone. Let's go inside first. All right. So let's go to the voxel cache. So this is just a global which stores essentially how to allocate it onto the GPU, and it just stores like the buffer IDs for the GPU and sometimes some custom allocators. So this is the old system, and this has been the new one. This is what the map was using, and now the map is becoming the new model. So, you know, I used to have model slices. A slice used to be a 3D slice, right, of a 4D animation. Not really good name, so we just called it a model, called it a keyframe now because it's what makes sense. We've got model instances, that's probably going to stay, right? So we keep that. This, we'll take that and we'll plop it down here. Now, the exist map and the material map, these go, because these are in the node tree now, right? They're part of this voxel material indices in the node tree. So that's no longer a thing. So these are no longer a thing. That's a slice, a model pool. We don't manage objects via anymore via like a lifetime. Sorry, they're not loaded. Yeah, the lifetime of the models is not managed now via via the renderer. It's actually done via the separate voxel module, right? So that's outside of the game and outside of the graphics code, and they both depend on it. So that all goes. The model frames, yeah, that's gone as well. I think it's all just goes. Yeah, it all goes. This is the how we upload it code. So there you go. Boom. Now, so that means all of this basically goes, which is cool. And even the shared stuff as well can go. But yeah, I guess we can always just look at Git if we think we're missing some, you know, we're struggling to understand something. So we can get rid of all this stuff. And yeah, it's currently at 2 frames a second. Yeah, it is going to be more than that. It's just a test. But yeah, so this all goes. Yeah, the inner and outer thing is interesting. We do want to preserve that, I think. Yeah, there was an offset of the volume. Yeah, we need that. So inner offset and outer dims, inner dims, and an offset. But I guess the offset could be calculated based on, it's just inner dims take outer dims. No, that's not true either. Yeah, so I think we'll need those three things actually. So let's go to the voxel model. Sorry, voxel shared encode. It's in the keyframe. Right, it's the way U8s, but it's not enough anymore. So we have sort of like an offset. So we need this so we can basically offset the model in local space and keep the animations. Animations can be different sizes, but they can. Yeah, they can be different sizes to save memory basically. And see, does that even matter at this point? Because we have got the tree now, and the tree basically saves memory, right? Because not all the leaf nodes are allocated anymore. So maybe the inner offset and that doesn't make much sense because they're basically going to be the same size anyway. Yeah, I think that's true because then it makes it more simple. So we'll get rid of it. If we need it, we can put it in, but yeah, I think it's not going to be that big of memory savings as it was before. Okay, back to where we were. So graphics, PK internal. So yeah, we'll get rid of just all this. Yeah, I could call it a timeline frame index. That's a nice name. Pass me had a good name. Where you at? Yeah, timeline. We have to have a way to set that. I don't think I've got a set function for that, actually, thinking about it. There was like, there was no... I pointed to it, though. Yeah, you get a pointer back to it. You can always set it yourself manually. Okay, so this all goes as well. Yep. Amazing. So in terms of the functions, we want to have a init. There's no longer an upload anymore because it's all just done asynchronously. Ooh. No, there is an upload. You upload the material indices, which is per frame. No longer any of this stuff. Man, this is great. We get to just go and delete everything. It's amazing. Delete. Right, so we can do the initialization code. We need a new voxel models buffer, and we need a keyframes buffer. So I wonder, there's a bunch of these counts everywhere, and right, I want to change all these, but yeah, there is going to be some kind of capacity. Now, these are actually defined by a number which is set in the voxel system, like at boot. So having these as constants is probably not a good idea. I had them here because yeah, for no good reason really. Right, so these can basically all go then. That's cool. So we can move away from these constants if possible. That would be great. So, anywho, so the instances, well, yeah, this should really be passed in via a, like for the game to decide, basically. So graphics, spec. Voxel model instances capacity. Alright, what's the maximum amount you basically throw at every frame? So you will basically, I guess, have that spec stored in here somewhere. Cool. So now in Voxel cache init, you can just store that. Oh yeah, use it. So you just do G. Right, what are we doing exactly? It's spec dot. There we go. Amazing. Now we didn't delete everything on the in the shared code. Let's just look around for it. So you need to make these new GPU. Oh, yeah. So Voxel model voc node hot node cold. We need Voxel model itself and then the keyframe. Yes, the voxel map render push constants, we'll sort that in a bit. But that's pretty cool. That's updated now. So there we go. So the next one is the models themselves. We need a buffer for all those. Those are located in, so there is some capacities you can get. They're called caps. So that's from the voxel system, which got initialized before the graphics system. So that will be caps dot models capacity voxel model. There we go. And so we've got the keyframes as well. And then we need there's the nodes. Surely they're here. Oh no, they've already been done. Yeah. We might just make them constants though. Yeah, let's make them constants because that way we can, let's get rid of all that. All this. Oh, this is amazing. Cool, so I think we take these, two of them, and move them out of here. So initialize them here. So this is earlier on, and this is because when we boot up the graphic, so the GPU system. If we want to have any fixed ID ones, we need to like do them right away before any other ones which are done. Yeah, we need to initialize them right away for some reason. I forget why that is. Yeah, otherwise the descriptor index gets taken. Maybe what we could do is tell it what we want, and then it should pre-bump those. But then, yeah, it could probably like pre-bump them or something like that. But anyway, this is the way it's done at the moment. I can always make it better later. Yeah, it'll probably be cool just to just make them into these buffer IDs. That way we can just access them without passing them into push constants, and there's like tons of buffers, right? And they're just hard coded into the shaders, which is cool. That way push constants can be used for other things as well. Other data can fit in there. But yeah, so we want to do something like this. Oh. Then it's explicit. Okay, cool. Right, so that's the initialization code sorted out for the Voxel cache. So the next thing is the upload. So the upload now is heavily simplified, since there's an async upload which happens on a background on a worker thread. So we just want to be doing this basically. Just uploading the instances. So this is the code, it's just got to change somehow. Just got to figure out how to do it. So it goes over all the, it uploads all the Voxel model instances in one go. And it then well, my wife's just come home. Let me see if she needs help. Just double check. Alright, welcome back. No, my wife is fine. She doesn't need help with the shopping. It's alright. Okay, what we're doing now. Yeah, so it used to, there's a graphics render voxel model instance. This is one of the GPU, sorry, the game thread makes. The game thread's like, hey, I want a new instance, and then it puts in some stuff. So maybe we're gonna have to start changing the public API now. Right, so what can we completely get rid of? Quite a lot of things. So we no longer have this sort of voxel model index thing. We can just probably pass in the ID. the voxel ID now. Render material indices and these sort of palettes. Sure, I guess we'll pass those up. Yeah, we'll leave that system alone. There's no point changing it. So no longer is there a voxel model render kind, but there is a voxel model instance still. So the voxel shape can now go because you can literally make shapes on the fly and generate them. And we can't do it from file yet. We're going to re-put that back in, but it's in a much better place now. So there's the render material. It's just a solid color. I don't think we'll do textures for this game. At least for the prototyping, we're not doing textures. Render voxel model. This goes. Goodbye to you. So we could just pass in now that voxel model ID, which is the shared thing between the game module and also the graphics module. And it can even be used in the voxel builder as well, which the magical voxel executable, which is pretty cool. So happy about that. So we've got the world from local transform, the animation time in seconds, and the material palette index. We'll keep that all there. So the render data, yeah, that's fine. And what's this about? Get rid of these function pointers. Oh yeah, and get rid of that one too. Right, this is great. Much better API now. So no longer do we have those either. Amazing. Right, so let's go to the graphics side of things and sort out that quickly. What are you complaining about? Here we go. This is what I want it to be doing. So no longer is there a deduplicate. Oh, is there a internal? Voxel models. Yeah, so essentially what we do is we have like a void array that we bump into, and then there's this sort of compile function. So that's what the render data is. It's oh, this is funny. So there's a thing called data, a thing called render data, and there's a field in there called data, and then inside the stack there's a field called data. So it's like render data, data, data. Yeah, we have one of those, and you basically just pump on all the things you want to render onto that void command buffer style queue thing. And then this function here will compile it into a bunch of contiguous arrays. So the internal graphics code can just like process it like the way it would expect it to. Anywho, so we've got to sort all this out. Not too big of a deal. So this all goes now. Goodbye voxel model. Happy about that. What else? And the compile function, I guess, gets changed around. Doop. Hey, did the void get let go? No, it didn't. Nice. Now it's saying it's done it all, but I don't believe it has. Was there something else we got rid of? Oh no, there wasn't. No. Yeah. Amazing, right? So now we go back to the actual implementation of the graphics, which is the Vulkan side of things. Man, this is amazing. Right, so back to here, we're trying to upload those new voxel model instances. So we want to get the source model. So we have a thing called voxel model now. We can do an object pull get. We'll We don't really have a way to do that yet publicly. We need to expose it, I think. Because what does this expose? Like, what do you want from the model? I guess you're going to get the timeline. Frame max. Oh, that's an interesting one. We haven't got that in there either. So it can work out basically what frame it wants to render, then you get the frames. And you store in the which model frame to render, well, which keyframe to render, right? So that's all we're basically trying to do. There's this sort of inner dims thing as well. We're not doing this anymore because we just do nodes, and the nodes should probably preserve space, enough space anyway. Oh. Okay, I think we're in a good place. Yeah, this was really cool. I was quite happy when I got it done, but probably not useful, and it will be in Git for a while. Yeah, the node tree would just save space, and this was just trying to save space, basically. We don't need to do it anymore. Right, so in... Sorry, Voxel shared encode. We're missing a timeline. Max or something like that. Frame max. We're also missing, you know, see, this capacity is a bit silly. Like, really, it's actually an enum. So voxel model material palette cap. It's technically what it is. Oh. Oh. So it's got a capacity of 1 or 2 maybe. What's the minimum? See, 1 would mean you basically store no data. You store no voxel materials. Now 1's not even possible because we have a 0 for air. We just waste 1. So yeah, 2, 4, 8. Yeah, we're talking about a number of bits basically, aren't we? Probably. Yeah, we're talking about it in bits. We say material. We call it material bits. But then bits makes it seem like it contains the bits, you know? It's not really a... You can call it a bit dim. So the dimension basically, that's what we'll do. So 1 bit, right? 2, 4. Right, so what was the numbers again? I've got them written down. I've written down like plenty of times. 1, 2, 4, 5, 6. Why not 3? Does 3 not work? Let's double check that quick. So it's, you got 32 bits. When you divide by 32 bits divided by 4 is 8. Yeah, there's plenty, right? So, yeah, it should have been a 3. I think I've done 3 before. 1, 2, 3. Oh, where is it at? Yeah, there is a 3. Just you skip 7. Because 7 and 8 bits doesn't offer you any more voxels in a single U32 word, basically. Because if you divide 32 by 7 and 8, it's rounded down, I think, is the same number. So 3, 4, 5, 6, 8, and 16. Those are the bit dims we'll support. So this allows us to do bit dim. Index dim, that'd be it. Cool, happy with that. So how many bits do we want to do for this? We support bit packing on enums as well. So yeah, we can just do 16 for now. No. So we need 1, 2, 3, 4, 5, 6, 7, 8, right? So that's only 3 bits. So 16 plus 3 is 16 plus 3 is 19, so it's nice. 13 remaining. There we go. So that's better. I'm liking that. Anywho, why was we doing all of this? Right, so let's just write this code out and then we can fix the voxel code that we've probably broken. Let's recode gen. Yes, this is 2 bits. Sorry, two U32s we've stored in, which is great. Nice and packed. All that data there. Cool. Right, what's next? So we need a function to fetch the voxel model because it is kind of publicly accessible, but there you go. Return pool, well, yes, it's object pool, get voxel model, model pool, model ID. So we can now just use that, the model ID, which is in source. So the one which is, the game thread gave this render thread. And there we go. Right, so now we can get this sort of like timeline frame max thing. So that would be voxel model, timeline frame max, deref model, and that's the code generated stuff which will extract this out. So yeah. Ooh, whether it's looping or not. Where did it get this? Right. Yeah, so I feel like we're going to have to move this into its own... Yeah, this is probably going to be the file format at some point. So we'll have to move it into another encoder file or something like that. But yeah, this is fine. So it should be the same representation on CPU, on disk, CPU and GPU, which is amazing. Because, well, yeah, it should be. Yeah. So we won't have transform data at runtime, which would be amazing. Right, so the flags unfortunately have to make it in here, but there's room. So we can just do this. Right, there's a flag, so we can just mark it there. And the thing is going to complain if we add more flags, basically, and so got that. Nice. So yeah, we can code gen that. Thought you would have code generated. Just too many compilers to see. It's okay. Right, let's just write it in like it works that way. I guess so we could check. Yeah, it's like it's not compiling. I will sort it out in a minute. Right, so yeah, well, it's flags, right? If it's in a loop, do a mod if not do a min. Then I think we've already checked this code. Right, so here we need access to the actual frames, but you can use, yeah, you could just do voxel model frames frame get with the voxel model ID and just get index 0, then you get the frames. Then the frames count you can retrieve. Or it's like a keyframes count, isn't it? These are the keyframes. Voxel model keyframes. And what are we doing? Are we searching backwards or something like that? Oh, sorry, it's equal to the one at the end. Okay. So, yeah, we need to get the frames count as a thing. Let's get that. The keyframes count. Mm-hmm. So we go over the keyframes. And find the closest one on the timeline, basically. Now this you can't get without making it to a little local. Got to extract out manually. So voxel model keyframe timeline start. So this thing. Right, what is this complaining about? I'll self-compare. Oh. Ah, right, I see. Do you want to call this the keyframe? Okay, there we go. Cool. Yeah, so I'm glad that's all sorted out. Now this is the code which worked out basically the offset and the matrix and all of this. I'm interested in that matrix a bit. The scale is for what though? Outer dims divided by. So if it's 16, it will get like a scale of 1. And yeah, so it's basically scaling the matrix for you. You don't have to worry about the model size and take that into account in the game code. So I think I want to keep with that. Aspect ratio. Yeah, that's all gone. That's due because I don't have the inner and out dims thing. So get rid of all that. So I think it's just... Oh. What happened there? Did I delete it? Yeah, I did. Right, so scale matrix. There we go. Looking good. And the outer dims is just the frame that we land on. We can get its dims, basically. So that'll be... you gotta be careful here. So... we should just call it dims. So that could be the voxel model keyframe dims. Pass in the keyframe that we found. So we could just call it KF or something like that. So KF equal the address of the frame index. So keyframe dereferenced. Then we float cast that Cool. So inside the model instance, the model instance just points to the keyframe that it wants to render, and it's able to go from there. So it's not really pointing to a model, it points to a model's keyframe. So that'll be right. It's interesting stuff to sort out there, that's for sure. Oh yeah, these won't have to exist anymore. So for the voxel render, we can just get rid of these actually, because they're global buffers now. Oh wait. Oh. Instance to render GPU. I think we'll keep that one. I deleted something we shouldn't have. Voxel. No. Graphics VK shared in code, I think. Oh, it's still right here. Oh. Yeah, we'll get rid of some of these still. Okay, so yeah, we just didn't... The descriptor ID we deleted. Okay, so get rid of those. They don't error anymore because they're global buffers anyway. Collision culling, all stuff to sort out. Yeah, this push constants was getting quite full. Thankfully made up room now. Right, so if we go back to that shared sort of header thing, we can actually get rid of these now. This one. Yeah, so this points to a keyframe index. So it'll just be a global keyframe index, and it can get that, which is cool. So yeah, spacing, I don't think that's even used anymore. Get rid of that as well. Right, I'm happy with that. That's very good. Okay. So keyframe, so it's just KF basically. Ooh. No. So the keyframe, the global keyframe index. Yeah, that would then just be voxel model keyframe start index plus the keyframe index that we landed on. Sorry, the frame index that we... And that'll be keyframe index. Cool. Right, so we're in a much better place now. That's the upload code sorted out, hopefully. I don't know why... Yeah, I'm confused why we're not seeing these show up, because it's able to generate these. Yeah, this file got regenerated, you see. Maybe there's a problem in the encoder file still. There's just a lot of other compile errors, it's difficult to find them. I guess let's just keep going with these compile errors. Getting closer though. So... Right, so this code can just all go now. This was the old code which made a voxel model, which was like a 3D array basically, but now we've got a tree. So this can all just go. So all of this goes the from file as well. We can definitely look into fixing the file loading later. And there we go. All gone. Right, so 2 places we can do now. We can either do the rendering code, or the game side code. The game side code should be quite small. Let's just start there. It'll be a quick win, and then we can come do the rendering side because that's gonna be a bigger job. We've got to sort out the scene shade as well and make that. Yeah, there's things. But if we're getting closer, the game side is gonna be a walk in the park. Let's just get that done. So game side. Right, game.h. So now we no longer have voxel map. We have a thing called a voxel model ID, and the map model ID. Yeah. And so we're just gonna have one map for now. We might have to split it into multiple ones for different sub-regions or something like this. We'll see. But the problem is definitely solvable in the current way we have it. So if we look around, why is it complaining? Oh, okay, generate a model where I can get rid of that. And I'm glad this code goes. Felt a bit weird. Right, so that's the async job. So when we're about to generate the payload on the game thread, right, for the render thread, we kick off a job on the worker threads, on the thread pool. And we say, right, upload all that voxel model stuff asynchronously, so it makes command buffers and just starts piling it onto the GPU. And hopefully, by the time the render thread has done its work, it's all ready to go, hopefully. So, we no longer pass a reference of the world map, right? The map just renders as an instance. So we've probably just got to push an instance of that actually. So let's give that a go. So this is the code. We've got to kind of restore. And, oh. Yeah, kind of restore because it's not this. So we push on a new instance. The ID is going to be the G-game world map model ID. The animation time is just going to be 0. Well, from local, let's do an identity. So that's a identity matrix 3D, I think. And then we need a material palette index for the map. We've still got to work that one out. So we'll just slap a big old to do in there. To do. So that's going to just be a big old 16,000. Sorry, 64K different materials up to that many. So it's got a U30, sorry, a U16 for each voxel. So that should be the game side code sorted out, I think. No, nearly there. So here's the voxel map, which gets generated. So that is, rather than a map, it's now a model. So it's so we do a voxel W So how many keyframes do you want? The one, the palette, how big do you want it? That's not really what the thing we want. Should fix that. So it's like a what is it? It's a yeah, but it's not even compiling yet. Material index dim set. Yeah, these are not. Oh, is that compiling? I wonder. So this thing is what's known as a voxel material index dim. Cool. So it's no longer a capacity, it's just an enum basically. We can turn that into an integer if we need be. We also need some kind of like timeline frame max as well, and I guess you could store that. Just be 0 initially. Right, so that should fix the compile errors in here. And now this map, the one keyframe, and we're going to be using the voxel model material index, and we want to do the dim at 16 bits basically. We'll call it bits rather than dims. Might be better. Yeah, stuff to think about. Anyway, we want to make a new frame. So we want to say, right, give me the keyframe. And then keyframe. And then it's keyframe set or resize. So resize the keyframe to fit the size we want. See, we shouldn't be doing too many of these sort of dynamic voxel model things, but yeah, we're doing it in the voxel builder and also in for the map, right? So anyway, here's the map. So resize. Now we simply just go over the dims. So I guess you could just put that locally into a thing, call it dims. Cool. And then we just change these guys. So it's voxel model keyframe voxel set keyframe. And then the get is just there to check to make sure that what we set is what we're getting back. So it's a voxel get. Nice. Right, so I think that's the game code. Oh, we need to do a new specification here. So graphics spec. You know, let's just say we want 60, 6555, 36. There we go. Maybe we want more, I don't know, but there we go. That'll do for now. Cool. Right, so now, hopefully all we have left to do is the graphics side of things. Interesting. This instance is to render capacity. Didn't we have... Yeah, because there's only like 15 bits, I think, in the visibility buffer. I thought I had some code in there to sort of check for that. There's like a triangle something. Yeah, I thought I had these things dotted about to sort of test it. That's what the visibility buffer gets, is one of these things. I used to have some asserts. Oh yeah, I deleted the code. Yeah, if the model that you make has more than this many things, or if the... Yeah, anyways. Gotta consider. Consider that again later anyway. We'll think about it. Right, so there's no voxel map reference. Shared. All gone here. Yeah, so render, right, we'll just slap a placeholder in there. Cool. Man, it's a shame that's still failing to compile. Right. Man, we're getting so close. This is great. So the old voxel model system had occlusion culling, and we definitely want to keep that. So we're just going to swap out to use those things. Yeah, what do we do? Right, I'll be right back. Welcome back. Okay, so where was we? Where was we? Yeah, so I want to know why the cogen is not cogenin. Oh, this is helpful. It's just failed on the thing we want to see now. So packed type min value 1 must be less than the max value 1. Right. That somewhat makes sense. What line was that? 23. Oh, wait. Oh. But the min value is not specified. Yeah, I think this is a bug in the encoder system. So that means then there's a min max and it's right. Oh, okay. It doesn't have a none. Okay, I see now. We need a none. Yeah. And that'll sort it out. There we go. Right, it's code gen. Amazing. Okay. So I'm glad we're there now. So I guess I saw out some of this sort of like occlusion stuff. Occlusion column. So there's two passes. Maybe we should have a way. Yeah, okay, I think it's fine. So yeah, let's just carry on with the errors. We can look at all the shaders in a second. No voxels this map. Render visibility. Man, it'd be cool to work on transparency soon. When we get the map sorted out, we can do transparency after that, because we'll need it for the game. Got some plans for that. I didn't delete that, did I? Graphics VK, voxel render VB. This guy. Oh no, it's not. Voxel model. Oh yeah. I see. Yeah, this is the map, isn't it? We'll be changing this code. It's kind of obvious now. Right. Shading. Get rid of that as well. And models clear, we can get rid of that. Yeah, so we'll need a way to somehow hot reload the models. Again, this is problems to solve another time. Right, so all that code is supposedly compiling now. but it's obviously not going to run because this shader code is completely messed. So let's get in there and fix the shader code. Oh, this is going to be good. So what we basically want to do is take that voxel render map fragment shader. And we kind of want to take this thing and like maybe make this a utility function somewhere, because it is going to be useful outside of here. Yeah, so there's that sort of GL frag coordinate. So yeah, I think what we would like to do is just make a structure and just generalize this just a little bit more and throw this in a header file somewhere. And we've got a lovely little function that's reusable, and we can use it for like other things later on. So we'll just call it a sort of reverse voxel. It's not voxel map, voxel model. Reverse voxel model. Well, this is interesting. Yes, these are all the parameters, the arguments, right? All the inputs. So you want that sort of matrix, right? That sort of your matrix 3D of a world from local and your local from world. We'll pull those both in. We'll have the ray origin and probably the voxel model index that you're rendering. Well, there'll be a keyframe. Here's the keyframe. Bit long. Okay. So you have a max T in there as well. So this is how we'll set it up and pass it in, because the parameters are getting a little bit long. That way the code the other side will be a bit more readable. So we'll just do something like this, I think. Let the compiler sort it out. Cool. Now, you can actually get the keyframe. Yep. Call it KF, I guess. So we'll fetch that via a one of these sort of hard-coded macros, sorry, hard-coded ways of accessing the buffer. So that will be model and then keyframes. So rather than map, it's model. And rather than map, it's model again. So that will be your model and your keyframe. Right, nearly there. Models, keyframes. Right, so now you got a keyframes buffer that you can pull. Yeah, I don't think the models need to be uploaded to the GPU actually. They might not need to be. So we might be able to get rid of them. That'd be cool. But yeah, so what are we doing here? We're doing like a keyframe index. Boom. So now from here we can access we can get the root node. So it'll be a node index basically. We'll just extract everything out that we need. So it's voxel model keyframe root node index. That's the thing. Then we extract out the dims. So the keyframe dims. So voxel dims, maybe you can call it. So that would just be something like that. So this is kind of doing some scale thing and like, you know, but do we have to be doing that? I think the whole point of using the matrices is the fact that it's done prior. So maybe yeah, I think we've got to do something a little bit more fiddly the other side. So where we do the cache upload for the voxels, where was in this matrix beforehand, we want to be doing it here. Matrices, man, these things. Yeah, so we want to produce like kind of a scale, which we already kind of did here. But yeah, we want to do a roundup. Local map X. Yeah, I think we want to produce a matrix that will go. Nah, maybe we can't do it that way. Yeah, we want to do it from local space. Hmm. Yeah, I think we want to rescale out the local space stuff. I think maybe. Yeah, so this probably just stays here actually. That makes it far easier. I'm happy about that. So yeah, Voxel dims this be called. This sort of map dims world space. Cool. Get the maximum element round up to nearest power of 4. Get the half dims. Get the... Do we call it map still? It's not a good name. Should call it voxel dims. Max power 4. Alright, anything else map related in here? So this should probably be called just dims in world space. It's not really world space though anymore. Because but yeah, we should probably call it... Yeah, I think it's in the full world space scaling though. We are going to be using the matrix in a minute. And this isn't going to make sense. We need some further scaling down. It would be nice to store it in the matrix, but then... Hmm. Maybe we do. Yeah, I got to have a think about this. Right, so I think it's a good place to put a pin in it, basically. I'm getting a bit tired. But, so what's left to do is just got to change the shader code. And then we should be able to try and get this up and running again. And we would have refactored it into supporting the voxel map will now be a voxel model. And we should be able to render this map that we simply procedurally generated, right? And now the system can account for like multiple models, right, with this sort of 4x4x4 tree node thing. And then after that, we can move on and getting the magical voxel thing working with this system and other things like that, which would be cool. And then we can be able to actually procedurally generate an actual map. We're getting close. It's definitely much better than it was before. So next stream should hopefully be on Sunday. I might have to cancel it. There might be something I'll have to instead, but hopefully it still goes on. So Sundays at 7:30 p.m. GMT +1, and Tuesday is the same time, and Thursday is the same time. Fridays at 2 p.m. GMT +1. But yeah, in the meantime, guys, there's a Discord channel if you can come chat, and there's also a YouTube channel where the streams go up, and there's also a video describing the game that we're working on and working towards. So there's that, and thank you for everyone who's supporting the channel. You can support the channel obviously by Twitch subscriptions, or there's a link to the code file where you can access the code and run it on your own local machine as well. Thank you for everyone who's supporting the channel. Appreciate you all, and I'll see you all in the next one. Right, God bless you all. Have a good weekend, and I'll see you soon. Bye.